All right, moving forward on to number 5. It says find all possible solutions on the interval negative 2 pi to 2 pi. And the problem reads 2 sine squared x plus 3 cosine x minus 3. One kind of interesting thing is actually this interval. It's actually from negative 2 pi to 2 pi, which is actually two revolutions on the circle, right? One is negative from 0 to negative 2 pi, and from 0 to 2 pi is positive, okay? So one is a negative and one is positive, just in terms of the regions that they're in. So how many solutions do you think we're going to have? What happened when we were going more times around the circle? On the previous problem, you know that when we had that 3t, we ended up with 3 times the number of solutions. Well, these two revolutions are going to give me double the number of solutions here as well. So let's go ahead and solve this out. Interestingly enough, I've got both sine and cosine in this function, and our hint says maybe we should use the Pythagorean identity. Go ahead and look at that formula chart and figure out which one your Pythagorean identities will match up with this. I'm hoping that you found the identity that says sine squared x plus cosine squared of x equals to 1. Okay, and I see this sine squared, so I'm going to go ahead and just get sine squared by itself in this formula. So we'll move that cosine squared to the other side by subtracting it, and I'm going to end up with sine squared of x equals to 1 minus cosine squared of x. And I'm going to substitute that in for this sine squared x. So now I've got 1 minus cosine squared of x plus 3x, or sorry, 3 cosine x minus 3 equal to 0. And I'm going to go ahead and distribute this 2 into this. So I've got 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. And let's just start combining down some of our terms. I can see that this 2 and this minus 3 are going to combine. Negative 2 cosine squared x plus 3 cosine x minus 1. And now I'm looking at this and I'm going, okay, somehow I'm going to need to break this down further. And it looks like a type of function we've seen before. This definitely looks like a quadratic, so I'm just going to pretend that these cosines are actually a different variable. Okay, so we're going to say substitute, and we'll just use x for cosine in this problem. Okay, and we're going to end up changing it back. So it's okay, whatever letter you want to use. You want to use x, y, a, b, u, w. Either way, it's fine. Negative 2x squared plus 3x minus 1 equals 0. And now I'm going to factor this, okay? So go back to some algebra notes if you need to, but remember, we're going to factor again. And by factoring this, we should end up with negative 2x plus 1 and x minus 1. Okay, and let's go ahead and rewrite this again and put back in the other pieces that we knew. We knew that x is actually cosine, so I've got negative 2 cosine x plus 1, and the second parentheses is cosine x minus 1. And remember, this was all equal to 0. Okay, so now we're in a position where we can solve this and each individual piece is going to be equal to 0. So let's set up each one and get our solutions. I've got -2 cosine x plus 1 equals to 0. And I'm going to go ahead and start moving things around. Let's subtract 1. -2 cosine x equals -1. Then we can divide each side by -2. And I'm going to get cosine x equals 1/2. Okay, the two negatives cancel each other out. Now let's think, what solutions do I get for that? We're going to say, hey, cosine is 1/2 on the unit circle twice. That is going to be at pi over 6 and 5 pi over 6. Okay, and if I were to go backwards and find my solutions for the negative portion, we're going to end up with -11 pi over 6 and -7 pi over 6. Okay, you may notice that each of these, to get the negative angle, I just ended up subtracting 2 pi. All right, you can add or subtract the period to find more solutions as long as you stay within the interval. Okay, so this kept me within the interval and I was able to find all 4 of these solutions. Now let's see the other ones that we get from that cosine x minus 1. So if we solve the second parentheses right here, we're going to get some new solutions. Cosine x minus 1 equals 0. Let's move that 1 over. Cosine x equals 1. And we're going to get two solutions for this again. We're going to have 0 and 2 pi. But there's actually also, let's find our next solutions the same way. We're just going to say subtract the period to find the negative one, so minus 2 pi. So I get -2 pi as a second solution, and this one is 0. But this one is kind of a repeat, so it doesn't really matter. Okay. All right, so my unique solutions currently 0, 2 pi, -2 pi, pi over 6, 5 pi over 6, 11 pi over 6, and 7 pi over 6. So my problem actually ended up with 7 different solutions. Okay, so the first 4 came from here, pi over 6, 5 pi over 6, -11 pi over 6, -7 pi over 6. Then from on the right-hand side, we had 0, 2 pi, and -2 pi. So all of these are the solutions within the interval -2 pi to 2 pi. And we find more solutions in the interval by adding or subtracting the period in order to fill in the rest of it. So the first circle is very easy. The first circle comes from the unit circle, and then we add or subtract the period to get more positive or more negative solutions. Okay. Okay. Problem 6. Cosine x plus 1 equals sine x. And we're talking about from 0 until 2 pi again. All right, so that is my interval. So I only want solutions in that section. And we're kind of stuck here because even if I moved things over, it's very difficult for me to say, hey, I can get my sines and cosines to somehow mesh together or cancel out so that I can solve this. And in this case, what we're going to do is we're actually going to have to square both sides, all right? And if I square both sides, you got to be careful to make sure we square the entire function like that, okay? So notice on the left-hand side, I made sure to put parentheses around the whole thing. And on the left-hand side, this is cosine x plus 1 times cosine x plus 1. And you have to remember that we're going to FOIL this out. All right. And when we start FOILing this out, cosine times cosine is cosine squared. We're going to get plus cosine then another cosine, and plus 1 as my last number. All right, first, outside, inside, last, we've got that. Let's combine our like term in the middle. And we got cosine squared of x plus 2 cosine x plus 1. And that's actually equal to this piece right here, sine squared of x. Okay, so now at least I'm kind of rolling here. I've got cosine squared x plus 2 cosine x plus 1 equals sine squared x. And again, once I've got these as squares, I can use the Pythagorean identity to help me. And the basic Pythagorean identity that we've used a lot by this point is sine squared plus cosine squared, and it's equal to 1. All right, so what I'm going to do is, again, let's just get one of these by itself. I'm going to go ahead and just get sine by itself since it's already on one side. So let's move over this cosine squared x. And now I've got sine squared of x equals 1 minus cosine squared of x. And I'm just going to take that and plug it in for that sine squared. So we've got cosine squared of x plus 2 cosine x plus 1 equals 1 minus cosine squared of x. Let's go ahead and move everything to one side, and that way we'll be able to get something more like a solution. So let's subtract 1. These 1's are going to cancel each other out. And I'm going to add cosine squared to each side. And I've got 2 cosine squared x plus 2 cosine x equals to 0. And I see some commonality between these two. What can I separate out or factor from here? My GCF, or greatest common factor, is going to be 2 cosine of x. Okay. Left inside, I'm going to have cosine x, and on the right one is plus 1. Okay. So when I took out a cosine, this left me with just a single cosine from this one and a 1 for this one. Remember, this is all equal to 0. So I can take each of these parentheses, and that section can be set equal to 0. And it's going to give me different solutions from each side. Cosine x plus 1 equals 0. And I'm going to go ahead and divide that 2 to the other side, and I'm just going to get that cosine x equals 0. And this one's pretty simple. We know that cosine is 0 at pi over 2 and at 3 pi over 2. Now, on the right, we can move this 1 over. Cosine of x equals negative 1. And there's only one place where cosine is going to be negative 1, and that's at pi. Okay. Now remember, this problem gave us an interval between 0 and 2 pi. So we're not going to have any generic answers. We're not going to do any of that 2 pi n. Now the only thing we need to watch out for is that we should kind of check our answers and make sure that they actually work. Because the problem is we squared, so we need to check for extraneous solutions. And how can I check for extraneous solutions? Well, if we go back to our original problem and plug in the numbers, we can see if that is actually going to give me an answer. Remember, extraneous solutions when plugged in would not give you the correct solution. Okay, so for example, cosine x plus 1 equals sine x. That was our problem initially. Okay, and if I plugged and checked each of these, I should get that this statement is true. So for example, let's just do pi over 2. So I've got cosine pi over 2 plus 1 equals sine pi over 2. And if I go to my unit circle, I can check this very simply, we're going to say, hey, cosine of pi over 2 is 0, plus 1 equals 1. And we can pretty much tell, yeah, that's true, that's correct, okay? We can do this with each of our solutions. So cosine 3 pi over 2 plus 1 equals sine 3 pi over 2. Hang on, so cosine of 3 pi over 2 is 0, plus 1 is equal to negative 1. Wait a minute, something seems wrong here. I'm going to get positive 1 is equal to negative 1. So this answer is no good to me. So this solution is extraneous. Okay, let's just check that last one. So we're going to go ahead and do same equation, and this time we're going to test pi. So we've got cosine of pi plus 1 equals sine of pi. So cosine of pi is going to be negative 1. We're going to add 1 to that, and we should get 0, which is sine of pi. And we can say, yeah, that's true as well. So my only answer that didn't work out was 3 pi over 2. Pi and pi over 2 both worked out as my solutions. All right, so that's checking for extraneous solutions. Remember, all you do is you go back, you plug in the answers that you got into the original equation. Now, the reason this happens, guys, why do we end up with extraneous answers? It happens when we square both sides, specifically because we might lose a negative sign somewhere. Because remember, when you square, sometimes signs cancel out. And canceled out signs lead us to extraneous solutions sometimes. So just take a second and check your work at the end by plugging those back in anytime you square both sides. Okay, guys, a couple final notes on solving trig equations. So solving means you're going to figure out what that x value is or whatever your variable is. And you should remember that our answers kind of come in two different forms. And the first one is kind of the interval form, and that's when they tell you, hey, your equation is limited to just this area, so all your solutions are in between those two numbers, or in that interval. And as an alternative to that interval one, we have a general form of answers, and the general form is when your equation doesn't have any restrictions or limitations on it. And that's the time when you're going to see examples of something like pi over 2 plus 2 pi n, okay? And what this end piece signifies is that this repeats multiple times, and it is always the period times n. And guys, those two come up based on what the question asks you. So if you have a question that doesn't mention an interval, you know that you're just going to write your answer as a general form, and you have to acknowledge the fact that it repeats. And if it does come in an interval form, you know that you are only going to give your exact solutions that are within that zone. All right, I hope this video helped, guys. Make sure that you practice solving trig equations.